Hello everyone, welcome back to another video. We've got a lot to cover today with the possibility of multiple rounds of severe weather across southern parts of the UK and Ireland during tonight and into tomorrow. And then on top of that, I'm going to do a quick review of expectation versus reality for Storm Eowan, what the impacts were and how the forecast turned out to be in real life. I'm going to start off though with showing a couple quick graphics just to give you a broad idea of what regions are at risk from what type of severe weather and when. And then I'll do a more detailed dive into the meteorology behind those forecasts. Starting off with the wind forecast, you can see a fairly large area of the southern UK and Ireland is at risk of wind today, though not as severe or exceptional as anything close to Storm Eowan on Friday. But still, southern parts of Ireland, coastal Wales, and much of southern and southwestern and then into southeastern England are likely to see 40 to 50 mile an hour gusts, possibly higher along coasts. And this is already on top of what was a very windy morning across parts of southern Ireland and especially southwest England. Wind gusts well over 70 miles an hour in places along the far southwest. But the main troublemaker for tonight in terms of the forecast will be a low pressure system, a very small one but a possibly substantial one, which is going to track northeast, moving up through the Bay of Biscay right now, then crossing the English Channel and then making this sort of track through parts of England. And it's on the eastern side of this low, and just to the south of the low centre we could see some severe weather, both very strong wind gusts, possibly even tornadoes, and also torrential rain. But anywhere in blue right now has the potential to see 50 to 60 mile an hour wind gusts overnight. Not everywhere is going to see these winds, but the uncertainty right now is too high to narrow down the forecast at the moment, and it may end up being that fairly large chunk of this area sees those winds, or they see winds maybe a bit below or a bit above, but this is just a rough guide. And then in purple in the hatching, that's where we're looking for a small corridor of potentially 60, maybe even 70 mile an hour wind gusts overnight during the early hours of from midnight to around 3 a.m, as you can see per the timings on this graphic here near the center of the low. And realistically, the zone of strongest winds is not going to be this large from here to here. It's probably going to be a much smaller zone, but as with the lighter blue zone, the forecast uncertainty is too high to create a very specific track at the moment. So this is just the rough best idea we have at the moment. We also, like I said, have some severe weather risks, so across parts of southern Wales, also possibly into parts of southern Ireland, but southern Wales, southwest England and southern central England into the southeast are likely to see showers and thunderstorms during tomorrow morning and into the mid-afternoon. In the stronger storms, we're going to see hail, locally some very strong winds, and maybe even a brief weak tornado. But the more interesting risk, in my opinion, is going to be the risk once again tonight of possibly locally very strong winds and maybe even a couple tornadoes. And just as before, it's unlikely everywhere in this red zone sees those severe weather impacts, but there's going to be a small corridor, probably only 50 to 75-ish miles wide, that does see significant impacts, and I'll talk about more of that now. I'll talk about that now. So this is the current weather picture across the northwest of Europe. We have this big low, a very deep one as well, 950 millibars, which I think has been named Storm Hermínia, Storm Hermínia by the Portuguese Met Service. And this actually deepened very rapidly in the middle of the Atlantic yesterday and on Friday night, and brought some very, very strong winds, likely over 100 miles an hour, in the middle of the sea. Luckily, this didn't hit areas struck by Storm Eowan, more on that later, but still, it brought some strong winds this morning and is going to be responsible for more severe weather tonight. And I'm going to draw your attention to this area of bright colours on the map here. Now what this is showing is bright precipitation, but the precipitation is there because we have a small featural disturbance which is currently moving into the Bay of Biscay and will track northeastwards. And this is what's possibly going to bring severe weather to us tonight. So that's that feature there, and let's make it out on satellite imagery right now. So this is windy.com. And you can see, currently, matching up quite well with our model forecasts. So this is that big Deep blue, obviously, an impressive curl of cloud with very strong winds likely here. In fact, a few buoys seem to be recording sustained winds of around 40-ish miles an hour just to the south of that low and to the north as well. But it's really this small disturbance to the south which has developed quite quickly that we're going to pay close attention to. And that's because it's an area of thunderstorms, and as those thunderstorms develop, they're going to release latent heat and likely turn what was initially just a frontal wave into a very compact low pressure system. And when I say compact, I mean very compact. And I'll show you some of the models right now. So this is the latest GFS 12 o'clock run. And this is what I think is a fairly reasonably likely solution at the moment. So what we would have, actually let me show you on this chart, I think it's a bit easier to visualize what happens. What we would have is this disturbance, it tracks to the northeast, and as it does so, it consolidates into the very compact low like I said. And ahead of it, you're going to get a band of torrential, heavy rain, hill snow across parts of Wales, mountain snow more likely, but especially on the south, we're potentially looking at some very strong winds. And in this GFS run in particular, we see winds of around 60 to 65, even 70 mile an hour gusts in places, just to the south and just to the east of that low. And in this particular scenario, it tracks like this, and so those winds translate across the kind of southeast corner of the UK. But you may think that's a kind of cut and dry forecast. If I show you, for example, the European model, there's nothing at all. It's just a very, very weak frontal wave. So what we're really looking at is a possibly higher impact scenario, but a very low confidence scenario. And we're going to break down now what I actually think is going to happen. First, we need to understand the current situation, and like I said, I just showed you the satellite imagery of our low developing here, but in my opinion it's developing more, or at least on par with, what the GFS and the ARPEG solutions suggest, which are more favourable for strong winds across the southeast. And that's because if you take a look at the water vapour satellite loop here, here's our big storm. To the south of that storm, where all these clouds are moving quite quickly, we've got a pretty powerful jet stream, and you can see that movement quite there. So all in this region is our jet streak. And at the beginning of this loop, we have this small area of blue shading here. And notice over the last few hours, the colours have become whiter, and now they're even verging on green. And what that is showing is the development of our heavy rain and thunderstorms over the last few hours. And if you've been watching this channel for a while, you know heavy rain, thunderstorms, precipitation, they all need lift of rising air, vertical motion, which helps the air to rise, it cools, condenses into precipitation. And so what the fact that this is developing fairly quickly in the last 6 hours or so indicates the presence of very strong lift underneath this jet stream. And that's what some of the uncertainty was about. Because if I show you the wind pattern now, so let's go to 300 hectopascals. This is around 10 kilometers above the ground, 9-10 kilometers. And it shows the jet stream, the level of the jet stream, quite nicely. So this was our low pressure system just to the west, and this was our very strong jet stream. Now, some of the models thought we were going to get this small frontal zone, just originally started off here yesterday and has now moved here. Some models, like the European model, thought this was not going to develop into much because it wasn't receiving enough vertical motion, enough lift from the jet stream. Then other models like the GFS disagreed and actually thought it would get enough to develop into a low pressure center. And what the satellite imagery is showing us is that the GFS model and those similar solutions, so I'll go through all the models in a second, but GFS, UKV, ARPEG, ICON, AROME, all those models which do show a significant wind threat in line with this graphic here, those models were picking up on the development, and the current satellite imagery is showing that development occurring. So already I'm starting to feel fairly confident in a more significant event than maybe what was initially expected. And if you focus again on that satellite loop, I mean, number one, the development of this is pretty rapid and quite quick, which is probably a testament to the level of lift that it is experiencing from the jet stream. Another thing to note is it's actually starting to get a fairly interesting low pressure type look, and I've paused the loop here just to analyse. We've probably got some sort of warm front or effective warm front in this region, likely some precipitation, even convection. We're also starting to get a hint of a sort of cloud head shape, which is really quite typical with a proper low pressure system, and a fairly rapidly strengthening one as well. So this is definitely quite an interesting look. Another thing to note is this dry air on the south side, And while this is not necessarily being dragged down from up above, like in Storm Eowan, this is potentially going to enhance the deepening, and then itself will activate maybe those processes of bringing in stronger winds from above and leading to stronger winds down at the surface as a result of that downward transfer of momentum. So potentially, I think we're seeing some sort of development like this, and we are possibly going to get a more consolidated and a much more well-developed low than even some of the higher-end models were thinking. So that's already kind of increasing my expectations to be in line with something like this, a fairly widespread wind event with possibly significant impacts in places. In terms of the higher end scenarios, and I'm going to go through the models now and take all of these with a grain of salt, but the highest end possible scenario we could see, which is if deepening occurs very rapidly and the low is very compact, so the pressure gradient is strong, is this kind of scenario here, which I would call the kind of 1987 type scenario. Now, don't get alarmed like saying this. We're almost certainly not going to get an event to that degree, but these highest end solutions have been showing some very rapid development, and what results is a sort of similar to a sting jet, not probably, actually, I mean, it could be, I'm not quite sure, but what essentially happens is these develop these lows very, very quickly, and on the backside you bring down those very strong winds from up above, and the highest end solutions are showing a corridor of widely 70 mph plus winds across the southeast. This was another one which brought a 1987 type solution with widely 70, even 80 mph winds across the southeast of England. Now, let me be clear, I don't think this is going to happen. This is just a highest end potential scenario, and for in the future, during tonight, when we're doing more of what's called nowcasting, to see how this low develops. Because where it's at now, like I said, the deepening is looking fairly not consistent, but fairly kind of rapid already. But if we assume the centre of the low is somewhere in this blue region, if we translate that to the jet stream forecast, well, you can imagine it's somewhere here. And I'm going to use the GFS for this because the European model, does not seem to be having the best handle on the jet stream. But if we imagine our low is somewhere in here, now remember, in terms of deepening of a low pressure system, we want divergence, which will lead to lift, because air spreading apart the upper levels, the air rushes at the surface to fill it, and the pressure drops. And you can see if we imagine our low is somewhere in here, we're starting to get a fairly decent pattern for rapid deepening, because you've got this weakening of the winds just to the north of the storm, which leads to divergence, and slight hints of divergence here as well. So overall, this is a fairly decent location to be, and especially if the low is geographically smaller, it doesn't need as much divergence to create the same effect of quick deepening and then eventually strong winds. And it's another one of those kind of feedback loops in weather, because if our low is initially stronger, then what happens is by the time it's maybe roughly here just to the northwest of France, it then creates its own enhanced divergence effect, because it injects energy, latent heat release, injects energy into the jet stream ahead of the low, that then creates extra divergence, as you can kind of start to imagine here. So the low then furthers deeper. In comparison, the European model, if it's going to load, so here we go. In comparison, the European model doesn't have as much of that look. The jet streak is a lot straighter and kind of unfragmented. So already, I think we're starting to rule out the less development solutions. It's just a question of how much does it deepen. Now, I showed you those really extreme ones. Do I think that's going to happen? No, I don't think that's going to happen. What I do think is going to happen is probably something like the GFS 12 o'clock run, which is the one I showed you earlier, with strong 60, maybe even 70 mph winds on the east side of that low, moving northeast, and that's going to bring strong winds to the southeast. Or another potential scenario is the French arpege model, and this is similar to the GFS, 60 to 70 mph wind gusts across the southeast during the early hours of this morning, likely making landfall, if you like, somewhere around midnight, and then transferring east, exiting the UK 3-4 a.m. And it is a fairly localised region. But just once again, notice how small that low pressure system actually is. So it won't take as much deepening to create a tighter gradient, and so we have the possibility of stronger winds than we would necessarily expect. And even more than that, I do think, because of how small the low is, the models themselves may be underestimating the kind of wind speeds we would get. They might not be resolving those processes properly. Now, there's something I want to talk about now, which is more of a severe weather threat. But if we take a look at some of the cross sections of the low, and this will be similar to some of the stuff I talked about in the Storm Eowan video, but we're going to do a moisture cross section. This is the GFS model here, and this is our little feature. If we take a cross section something like that, let's get cross section, you can see we've got hints once again of that descending dry air signature that we talked about last time. So this is the boundary between our stratosphere and the troposphere, and dry air, that's stratospheric, there's generally much stronger winds. And notice how once again that boundary is slightly shifting down to the south, and this is possibly, or not possibly, this is likely the model simulating a deeper low which drags in the stronger winds from above, the stratospheric air from above, and that kind of enhances the deepening process even further. And this is not the only model that was showing it. The Icon model was showing this as well. And this is a mix between concerning and interesting, because if we do start to get this kind of dry air descending into the low, well, it's unlikely it's going to reach all the way to the surface, but this does raise the possibility of localized fairly strong winds, and so I'm inclined to agree even more with these kind of scenarios of 60, even 70 mile an hour wind gusts. Now another thing is the possibility of a Stingjet-esque type feature, or some sort of kind of convection related severe weather threat. And I'm going to go through this paper now. I'll put the link in the description. I highly recommend you read it. But in the UK, we often get these type of setups with mesoscale lows and an associated tornado and wind damage risk in in this case it's frontal rain bands. This is more of a kind of separate mesolow. This is a very good paper. Like I said, I highly recommend you read it. I'll put the link in the description. But what this describes is often when you've got a frontal band, which is shown here, this blue, that's showing a cold front, in the presence of very strong vertical motion. In this case, this is a jet stream. What you can happen is those mesolows developing, and then on the tip of those lows, you get convection. And let's see, yeah, so these are some radar imagery. You get convection in a kind of sort of comet head type shape like this, a bit of a hook echo shape. And on the tip of that convection, you can often get very strong winds and even tornadoes. And that's a result of the downdrafts descending, and the kind of shear instability spins up vortices, and you get tornadoes slash strong winds. And some of the models have been producing similar output to those kind of scenarios. I mean, this is the high resolution Eowan model right here, and you can see that kind of signature does look fairly familiar. You've got that kind of hook comma look, and it makes sense if you've got dry air descending around the backside. You then have these downdrafts, and possibly on the tip of that low, you're going to get strong winds and maybe even a couple tornadoes. And that strong wind risk is already being picked up by the Eowan, as you see there, 60 to 70 mile an hour wind gusts tracking through the east of England. But I need to be clear that this exact model run is not going to verify, and that's because the really precise location, if we get one of those mesolows with convection around the tip and strong winds, even a tornado threat, we don't know exactly what corridor it's going to pass through. And hence, in the graphic I made where we've got the red hatched area, it's possible maybe it comes on this side, it's possible maybe it comes on this side or in the middle, but it's unlikely everywhere is going to see that enhanced severe weather risk. Now, another thing to consider is if the development is too much like a classic low pressure system where we've got a cold front and then a warm front, then that maybe that risk will be reduced. Instead, that's going to be traded for a more widespread strong wind gust risk. But I think you're starting to sort of get the picture. A low is starting to develop, possibly more than expected, and in this case we both have potentially frontal bands and large amounts of ascent. So either we're going to get a mesolow with probably some convection related wind gusts, maybe a couple of tornadoes, and a broader severe wind risk, or in the higher end scenarios we would have a more widespread damaging wind risk across the southeast. But this graphic is, in my opinion right now, the most likely outcome. 50 to 60 mile an hour wind gusts here, potentially 60 to 70 mile an hour wind gusts somewhere in here, maybe the risk of a couple tornadoes. They'll probably be brief, but also strong wind gusts. So that's kind of the weather risk for this evening. It's going to be quite short-lived, starting maybe around 11 o'clock midnight, exiting around 3-4 o'clock and on Monday morning. Do follow my Twitter for live updates on that threat. But this is potentially going to be quite interesting and take some people by surprise, I do think. I think we could be seeing amber level impacts. I don't think they'll issue a warning due to low confidence, but possibly we're going to see a corridor of strong winds. As that low then exits the following day, what we are left in is a still unsettled but also fairly unstable weather pattern. And if I go to the GFS for 12 o'clock tomorrow, you can see we've got our well, there's our low, which is exit to the northeast, but also we've got these southwesterlies, and they're quite showery as well. They're quite unstable, and the temperature contrast between the colder air at the upper levels and the slightly milder air of the sea will create some instability, especially around coasts. Not only that, we also have very strong winds just above the ground. This is our classic chart that we like to use for looking at winds just above the ground, 850 millibars, that's around 1.5 kilometers above the surface. And you can see we've got a large area in red and even in yellow. And so what that does mean is if we do get some instability, we possibly will get convection, so storms and showers, bringing these strong winds down to the surface. And I just took a random sounding here. And this shows that kind of risk quite nicely. We've got a very, you can't see that panel, I just realised. You've got a very, very thin sliver of instability. But some of the actual convective models, like the Aquarium, do show more than that. As you can see, potentially, I mean, as I said, generally limited to coasts and just inland, but potentially a few 100 joules per kilogram of Cape, which, if the wind shear is strong, as this photograph indicates here, could be enough for some marginally severe storms, mainly in the form of severe wind gusts, because those strong winds just above the ground will get transported to the surface. So possibly, in the stronger storms, 60-mile-an-hour wind gusts or so. Another thing, if we've got updrafts and the background temperatures are very cold just because it's winter time, we will have a risk of small hail pellets. Now, the wind shear may locally, especially along the coast, just be enough for a very, very weak tornado. And we can take a sounding here where the low-level shear is highest. So this wind shear here, you've got a fairly nice curvature in that lowest kind of 1 to 2 or 3 kilometers. And if you were to get a kind of supercell-ish structure with a mesocyclone, there would be wind shear in here to maybe create a brief weak tornado or two. But me personally, I'm not particularly sold on this risk. I think the highest severe weather risk, will be tonight. Having said that, though, the convective resolving models like the Eowan and the UKV are picking up on the potential for squally showers during the day tomorrow. You can see 9 AM. This is the simulated radar, so don't take the location literally, but heavy showers, possibly hail, a couple strikes of lightning, and strong wind gusts. And you can see those wind gusts are modelled to be fairly high. You can see over the English Channel 60, 70, 80 miles an hour. Even inland, though, where you get a strong one, 60, maybe 70 miles an hour. I mean, especially across the southwest, early on in the morning, 7, 8 AM, we could be looking at a fairly substantial strong wind threat. And you can see the same thing on the UKV there as well. So there's our low that we talked about earlier. And on this run, this actually does bring wind gusts locally 70-ish miles an hour just to the south of the low. But like I said, uncertainty exists on exactly where that would be, so don't take it too literally. But what I was going to show you is this kind of more showery risk. You can see UKV showing a couple showers or thunderstorms with an attendant strong wind risk. And we're going to have strong kind of low pressure gradient winds anyway across parts of Southern Ireland, Wales and Southern England tomorrow as our low, I think Storm Hermina, as I said earlier, pushes into the UK. So that's going to be the general forecast for the next 24 hours or so. Pretty unsettled, possibly multiple severe weather risks. Also, I forgot to talk about the potential for very heavy rain, actually, across the evening, during the evening, across Midlands and the Southern England tonight with that low pressure system. But I talked about that more in detail earlier. Now we're going to do a quick review of Storm Eowan. So Storm Eowan, in my opinion, was just as severe as we thought. The pressure reached around 940 millibars as the storm rapidly deepened, and we saw a new Irish wind gust record all the way from 1945. The new record, well, it was previously in 1945 112 miles an hour. Now it's 114 miles an hour, and we've seen some reports of wind gusts as high as 120 miles an hour, but on unofficial stations. Now, I talked a lot about the storm surge risk in Galway Bay, and I'll put the link for this in the description because it's an amazing video. But we did see this materialise actually, and the risks were pretty severe. This is from Galway at Aquarium, which I think is an aquarium, and you can see that storm surge just as it was in a hurricane, driven by those strong winds on shore and caused very rapid flooding. So this was the early hours, I think it looks like just after 12. And then the flooding started around 2:30. So notice the difference. It would have just been a couple hours between this photo and this photo. As you can see, a proper storm surge flooding of multiple meters, likely causing severe damage hopefully not severe damage, but significant damage in places. Here's another video, and you can see the water is physically pushing inland, and even if you compare the start of the video, the water gets deeper as you run through, and this is a very classic storm surge. But you can see I think these are my retweets of the storm as it was happening. It did also cause some severe structural damage. This is a wind turbine, obviously, which has collapsed, so it takes a lot of damage to do that. This is a video of a roof being ripped off in west coast of Scotland. Even inland, we saw gusts to 90, 100 miles an hour, as expected. And this video of scaffolding falling down. This is a video from Glasgow. So it was, as expected, a very severe storm, and in my opinion, probably one of the worst to strike Ireland of the century so far. Maybe, if not the worst. But that's about it from this video. If you have any weather-related questions, do put them in the comments. Also, follow my Twitter here for some updates on the storm tonight, especially as the uncertainty is high, so I won't be able to keep posting videos. But if you're in these regions, pay attention to the radar, pay attention to the forecast, and take care. Thank you very much for watching. Bye.